Hello students, I hope your path exam went well. The 9th to 10th path paper discussion. First question we're told that two complementary angles are in the ratio 13:5. So we can take them as 13x and 5x, right? And they're complementary, so the angles, they add up to 90 degrees. This gives us the value of x as 5, which gives us the two angles as 65 and 25, right? 13x and 5x. Okay, which of the following is not a criterion for congruence, right? So side angle SSA is not a reliable congruence criterion, right, for being certain about if two triangles are congruent or not, right? Now, which of the following, now for the third question, which of the following is not the solution of the equation x plus y equals 7? So 3 plus 4 is equal to 7, 0 plus 7 is equal to 7, 1 plus 6 is equal to 7, but 2 plus 4 is equal to 6, right? So it's not a solution. Okay, here we have x equals 53, it's vertically opposite, and we also have x equals y, right? And they both equal to 53. So x plus y is equal to 53 degrees plus 53 degrees, which is 106 degrees, right? Okay, so this question says the point which is the mirror image of the point minus 3 comma 5 about x-axis is in the which quadrant? All right, so we have the point minus 3 comma 5, which is in the second quadrant. Now its image about the x-axis will be here, right, in the third quadrant. So question number 6. So we're given an 8-digit natural number PA2025TH, right? All of these are digits. So 8-digit number which is divisible by 99, right? So we have 99 divides this number, right? And it's also given that PA by TH, the two-digit numbers, they're in the ratio 7:2, right? So what is the product of the two-digit numbers PT into AH? All right, so I think we have to find what PA and PATH the digits are, right? So what can we say about PA2025TH? So can we write it as PA2025TH equals PA into 10 power 6 plus 20 into 10 power 4 plus 25 into 10 squared plus TH. Now when this is divided by 99, what do we get? We get the remainder as, so we can again write this as PA into 999999 plus 1 plus 20 into 99999 plus 9999 plus 1 and 25 into 99 plus 1 plus TH, right? So when this is divided by 99, we get remainder as PA plus 20 plus 25 plus TH, right? I mean, this obviously is greater than 0, but because PA and TH are less than or equal to 99, because they're both two digit numbers, this whole thing is less than 99 plus 20 plus 25 plus 99, right, which is equal to 243, right? So this sum here, that is PA plus TH plus 45, is greater than 0 and less than 243, right? But it should also be divisible by 99, right? Because the whole number, this whole number is divisible by 99, right? This whole number is divisible by 99. So its remainder when divided by that number should also be divisible by 99, because we should end up getting a remainder of 0, right? So this whole thing should be divisible by 99, right? So PA plus TH plus 45 should be equal to 99 or 198. It can't be equal to 297 because the sum itself is less than 243, right? Now we know that PA is equal to 7 by 2 TH, so we can put that here. We get 9 by 2 TH plus 45 equals 99 or 198, right? So from this we get 9 by 2 TH equals 54 or 54 or 153, right? From which we get TH equals 12 or 34, right? And we know that PA is equal to 7 by 2 TH, so which equals 42 or 17 sevens are 119, right? But PA can't be 119, it's a two digit number, right? So PA is 42 and TH is 12, so the number is 42202512, right? This is the 8 digit number that we wanted. Now what are they asking us? PT into AH. So P is 4, T is 1, so PT into AH. So 41 into A is 2 and H is 2 into 22. That gives us 904. I'm sorry, 902, right? So the answer to this question is option A. Okay. So in the 7th question, they've given us a grid of squares, right? So all of these are squares. So this is a square, right? This is a square. This is a square. This is a square, right? This is a square, right? Okay, so let's try to use the diagram and find the value of the angles, right? So let's extend this. Right? Yeah, and right, so we can flip this, right, to the other side. We can draw it like this, right, and we'll get a triangle, right, because see, this line is straight, right, because this here covers, so this triangle here comes congruent to this one, right? So I mean, we can flip this and we get a bigger triangle, right? And this angle becomes beta, this whole big angle, right? And now what can we say about these two angles, right? Okay, let's extend it down here as well. Right, and now right, so let's see this. So this one here is a square, right, because this here is the diagonal of a square, this here is the diagonal of this square, right? So what is this angle? It's 45 degrees, right? This angle here is also 45 degrees. So in this big triangle here, we have alpha plus beta plus gamma plus 45 plus 45 equals 180 degrees, sum of interior angles of a triangle, right? So alpha plus beta plus gamma equals 90 degrees. So there's no option 90 degrees, so we go with none of these, right? Okay, let's move on to the 8th question. Okay, in this we're given a few clues, right? So let's start with the second clue to identify the number, right? 7, 6, 4 and 2. This says that none of the digits are correct, right? So which leads us to here. Let's go to the first clue. So in the first clue they're saying 2 digits are correct, but they're in the wrong places, right? But we know that 4 and 2 are not correct, right? So 4 and 2 are not correct. So 1 and 3 are correct, right? So 1 and 3 appear, but they don't appear in these places that's given there, right? Okay, let's move on to the third clue. In the third clue, they're saying one of the digits is correct and in the right place, right? But again, from the second clue, 6 and 2 are not correct digits. So 2 and 6 are not correct. So either 9 is correct and it's in the right place, or 8 is correct and it's in the right place, right? So let's take 8 is correct and in the right place, right? Okay, let's move on to the next clue. In the last clue, 7 can't be correct, right? Because it appears in the second clue where none of the digits are correct. So 7 is not correct. 9 can't be correct because in the previous clue only one digit is correct and we assumed it to be 8, right? So 5 and 0 are the two correct digits. Now 0 obviously can't be in the right place, right? So, but 5 is the first digit. So we are left with 0, 1 and 3. So for all statements to be correct, we can't have 3 numbers left, right? 0, 1 and 3. So our assumption that 8 is in the correct place was wrong. So 9 is in the correct place and we don't know the other digits, right? So let's start again. Now let's come back to the fourth clue. Fourth clue says 2 digits are correct and one is in the right place and the other is in the wrong place, right? So we know 7 can't be correct and we know 9 is correct, right, from the previous clue. And we know that so the other digit is in the right place. So the other digit can't be 5, right? Because 5 can't be in the right place. So the other digit is 0, right? So we're left with, so we know that 9 and 0 are in the right place. Now we're left with the digits 1 and 3, right? So 3 can't be here in the third position because in the first clue the 2 right digits are not in the right place, right? So 3 has to be in the last place and the third digit should be 1, right? And there was a small change in the question. Which of the following is not true, right? So now that we have the number 9013, yes, it is a prime number. Yeah, and its thousands digit is divisible by its tens digit, right? 9 is divisible by 1. And its units digit is 3. So the option that is not correct is that it's divisible by 11. It's not divisible by 11, right? So the alternating sum, the difference of alternating sum gives us 9 plus 1 minus 3, which is 7. So the only incorrect option is option B. Okay. In the ninth question, we're given x plus 1 by x equals 5. And we're asked, what is x bar 11 plus minus 7 x bar 7 plus x bar 3, right? So, it's given as root 5. So, can we square both sides? If we square both sides, we get x square plus 1 by x square plus 2 equals 5. So, x square plus 1 by x square equals 3, right? Let's square it again. We get x bar 4 plus 1 by x bar 4 plus 2 equals 9. So x bar 4 plus 1 by x bar 4 equals 7. Now let's multiply the numerator and denominator with, let's take LCM of all the terms. We get x bar 8 plus 1 is equal to 7 x bar 4. So we get x bar 8 minus 7 x bar 4 plus 1 equals 0. And let's multiply this whole thing by x cube or not. So if you see this here, this x bar 11 minus 7 x bar 7 plus x bar 3, we get this is equal to x bar 3 times x power 8 minus 7 x power 4 plus 1, right? And we know this value of this is 0. So the value of the whole thing must be 0, right? So it's option B, 0. So let's move on to question number 10, right? So we're given that x plus y equals 6 and xy equals minus 12. We're asked to find this expression, right? So we can rearrange the terms in this expression and write it as x plus y plus x square by y plus y square by x plus x cube by y square plus y cube by x square, right? So this gives us x plus y plus x cube plus y cube by xy plus x power 5 plus y power 5 by x square y square, right? We know x plus y is 6 and x cube plus y cubed is equal to x plus y the whole cubed minus 3xy into x plus y, which gives us x cube plus y cube equals 6 cubed minus 3 times minus 12 times 6, right? Which gives us 216 plus 216, which gives us 432, right? We can also find x square plus y square. X square plus y square equals x plus y the whole square minus 2xy, which is 6 square minus 2 times of minus 12, right? Which gives us 36 plus 24, which is 60, right? So x square plus y square equals 60. Now x power 5 plus y power 5 equals x square plus y square into x cube plus y cubed minus x square y square into x plus y, right? So x power 5 plus y power 5 equals 60 into 432 minus of minus 12 the whole square into 6, right? So this gives us 60 into 432 minus 144 into 6, right? Okay, let's keep it like this. It may simplify later. So we have to find this thing right here, right? X plus y plus x cubed plus y cubed by xy plus x power 5 plus y power 5 by x square y square. Now we have all that we need, right? So x plus y is 6, x cubed plus y cubed is 432 divided by xy, and xy is minus 12, plus x power 5 plus y power 5, that is 60 into 432 minus 144 into 6 divided by x square y square, that's 144, right? So this comes out to be 6 minus 36 plus 180 minus 6, right? So which gives us 144, So the answer is option D, 144. Okay, in this question, what are we being asked? We're asked to find the area of triangle ABC, right, with vertices 1, 3, 5, 1 and 4, 4, right? So what fraction of the grid is covered by the triangle? So they're asking what is the ratio of the area of the triangle to the area of the whole grid, right? The area of the whole grid is just 6 into 5, right? That is 30, right? Now what is the area of the triangle? So let's draw these lines here, right? Let's draw these 3 set of parallel lines and this, and let's name the points as X, Y and Z, right? So what do we need? We need area of triangle ABC, which is equal to area of trapezium XACY plus area of trapezium YCBZ minus area of trapezium XABZ, right? So it's basically this whole area, this whole area plus this whole area minus this whole area, right? So we know this height is 3, this height is 4 and this height here is 1, right? And this length is between xy is 4 minus 1, which is 3, and this yz length is this length here, yz, it's 1, right? So we have the area is equal to area of trapezium XACY, which is 3 plus, so half into 3 plus 4 into 3 plus area of YCBZ, which is half into 4 plus 1 into 1 minus area of XABZ, right, which is half into 3 plus 1 into 4, right? So this gives us 21 by 2 plus 5 by 2 minus 16 by 2, right, which is 10 by 2 or 5. So the area of triangle ABC is 5. So the ratio is 5 by 30, which is 1 by 6. So option A, 1 by 6. Right? Next question is a rectangle with sides parallel to x-axis and y-axis has opposite vertices located at 15, 3. Okay, so they're talking about this rectangle here, right? So this is a rectangle. Now a line is drawn through points A and B, and another line is drawn through C and D. How many points on the perimeter of the rectangle lie on at least one of the two lines, right? Okay, let's look at the diagram. Okay, so let's extend this line AB, right? So for every column, for every 3 columns, 1 row is being covered, right? If we extend this line here, so we can keep extending it that way. Right, and it touches this corner of the rectangle, right? Like this. And this one here, for every 2 rows or 2 columns, it's covering 1 row, right? So we can extend this line as well. Right, but this does not intersect with the perimeter of the rectangle. So how many points lie on the perimeter of the rectangle? I mean on one of these two lines. It's just one of these points, that is this point right here, right? Okay, let's move on to the next question. Okay, so in question number 13, we're told that in this equation the coefficient of y has been hidden, right? It's been hidden, as you can see here, but we know it's a positive integer. Okay, let's take the hidden integer as k, right? So let's write this as 2x plus ky is equal to 25, right? Now we're being told the equation has at least one solution where x and y are positive integers. Both are positive integers, both x and y, right? How many different values for the hidden coefficient, that is k, are possible, right? Okay, so let's write down the cases. So ky equals 25 minus 2x, right? So because both of these are positive, k and y, the right hand side should also be positive, right? So we have ky equals 25 minus 2x, but this should also be positive, right? So x is greater than 0, of course it can be 1, and it's less than 13, because if it becomes 13 then this whole thing becomes negative, right? But it can't be negative, right? So let's take case by case. When x equals 1, ky equals 25 minus 2, that is 23, right? If ky is 23, k can be 1 or 23, right? Okay, if x equals 2, ky equals 21, so k can be equal to, we've already written 1, right? 1, 3 or 7 or 21, right? Let's move on. X equals 3, ky will be equal to 19, so k can be 19 here. It can be 1 also, but we've already written down 1 as one of our solutions, right? And for x equals 4, ky equals 19, so k can be 17. For x equals 5, ky is equal to 15. Now k can be 3, 5, or we've already written 3, so 5 or 15, right? For x equals 7, we have ky equals 13, so k can be equal to 13. For x equals 9, we have ky is equal to 11, so k can be equal to 11. For x equals I'm sorry, did I miss? Yeah, so this was supposed to be 8, right? For x equals Oh, I've been missing numbers. So this should have been x equals 6, x equals 7. So for x equals 8, we have ky equals 25 minus 16, which is 9. So k can be equal to 1, 3 or 9. So k, we've written 1 and 3 already. So k equals 9 is another solution. And for x equals 9, we have ky equals 7, from which we get k equal to 1 and 7, but we've written both of those down already. For x equals 10, we have ky equals 5, so k can be 105. X equals 11, ky equals 3, so k equals 103. For x equals 12, ky equals 1, so both k and y should be 1 for this case. But I mean, we've already written down all the possible numbers that k can take. Let's now count them. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So k can have 12 values, right? So the answer is option B. Okay, let's move on to question 14, right? Alright, so we're being told that the whole parallelogram, so area of ABCD equals 1, right? And I want you guys, okay, so what are we being asked? Two diagonals intersect at M, right? Okay. Another point P lies on CD. E is a point on the intersection of the line segments BD and AP, right? So this is E and this is F, okay? And they're telling us the sum of the areas of triangles AED and BFC, right? That is area of AED plus area of BFC is 1 by 3, right? Okay, what are they asking us? They're asking us what is the area of the quadrilateral EMFP, right? So what is the area of this quadrilateral here that's formed, right, by the intersection of all these lines? Okay, so area of APB is half of the area of the parallelogram, right? Because it has the same base and the same height, right? So half into 1, which is half, right? So area of APB is half. Now how do we get APB? Okay, we need to remove this area here, this area here and this area here for the quadrilateral, right? Okay, so what is area of AMB? Area of AMB, right? Okay, so M is the midpoint of AC, right? Because it's a parallelogram, diagonals bisect each other. AM is equal to MC, right? So in triangle ABC, right? So area of ABC is also half because it has same base as the parallelogram and same height, right? And a median, that is this line BM, will divide the triangle ABC into two triangles of equal area, right? So area of AMB is half the area of ABC, which is already half, right? So half times half is 1 by 4. So area of AMB is 1 by 4, right? Now similarly, area of AMD and is same as area of BMC, they both are congruent triangles, they have same area, right? Which is equal to 1 by 4, right? Area of AMD is equal to area of BMC, which is equal to 1 by 4, because we know BMC's area is also 1 by 4, it's same as AMB, right? So now we have to find area of EMFP. Area of EMFP is equal to area of APB, right? APB minus area of AEM minus area of BFM plus, minus area of AMB, right? So we're from this big triangle's area, we're subtracting this, this and this, right, to get the area of the quadrilateral. So which equals area of APB we know is half, right? So this is minus. So what is area of AEM? Area of AEM is, so this again is this whole triangle minus this area, right? So half minus area of AEM is area of AMD, right? Area of AMD minus area of AED, right? Again, similarly, area of BFM is area of BMC minus area of BFC, right? And again subtract, we know area of AMB, which is 1 by 4, right? So this becomes half minus 1 by 4, which is 1 by 4, minus area of AMD we know, right? Area of AMD is 1 by 4 minus area of AED minus, again one, area of BMC is also 1 by 4 minus area of BFC, right? So this equals 1 by 4 minus 1 by 4 minus 1 by 4 plus area of AED plus area of BFC, right? And it's given in the question that the sum of these two areas 1 by 3. So 1 by 3 minus 1 by 4, which gives us 1 by 12. So the answer to this question is option D, 1 by 12, right? Okay, let's move on. All right, so question 15, right? We've been given two figures. So left hand side figure shows a shape consisting of two rectangles, okay, either these two rectangles or split it like this, and these are also rectangles. It's just given to tell us that all of these angles are 90 degrees, right? This is 90, this is 90, this is 90, and this is 90, right? Okay, now they're moving things around, right? Okay, if this is 11 and this is 13, what is this? This length is 11 plus 13, right? Which is 24, right? Okay, now here we're moving things around. So we're putting this here, right? We're taking this triangle we're taking this triangle here, right, and we're turning it around like that, and we're fitting it here like this, right? That's what we're doing, right? So if it fits perfectly, then this side should also be 11, right? This length should be 11. Okay, and what else are we doing? We're taking this one right here, right, and we're turning, I'm sorry, we're turning this like that and fitting it there like this, right? So that we end up getting this figure that's shown in the right, on the right, right? Now if this fits perfectly, then this length should be 24. But if you think about this whole length, right, it's nothing but this length, and that comes out to be 13 plus 24, which is 37, right? So we have in our original diagram that this is 11, this is 13, this is also 11, this is 37, and this is 24, right? So let's find the area. So the area is 37 into 24 minus 11 into 13, right? This missing area, because we're doing the area of this whole rectangle minus this small area, which gives us 888 minus 143, which is 745, right? Option C. Okay, let's see question. Okay, question 16. It says path is a trapezium, right? The sides PA and TH are parallel, right? Also, angle PHT is 120 degrees, right? All right, and we've also been given that PH, so this side equals this side, right, and is equal to 1/3 of PA. Okay, so it's both of these sides are 1/3 of this whole triangle PA, right? All right. Okay. Now let's say this is x, this is x. Can we split PA into 3 equal lengths, x, 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 right? And so this angle we know is 60 degrees because TH is parallel to PA, right? And let's name these points x and y. Now let's connect this to this, right? So this side is x, this side is x, this side will also be x, right? Because it will give us an equilateral triangle, right? So this becomes 60 degrees, this becomes 60 degrees. Now we can similarly connect this here, x to t and t back to y. So this gives us so many equilateral triangles, right? 1, 2, 3 equilateral triangles, which has all its sides x, right? So if we take this triangle here, right, we have this angle is 120 degrees because it's a linear pair with the 60-degree angle here, right? And we have these two sides are equal, so these two angles are also equal and they're equal to 30 degrees. So the answer is option C, 30 degrees. Okay, this is a very straightforward question. Question 17. In a rectangle path, couple draws a zigzag line. So this is the zigzag line, P, X, Y, Z, H, right? Okay, and the angles are as given, right? So we can draw a few parallel lines ourselves like this, passing through x, y and z, right? So this angle here will be 10, so this will be 4, so this small angle here, right, will be 4 degrees. Okay, let's actually zoom this in, right, because it doesn't seem very clear. Okay. So this angle here is 10 degrees, which gives us this angle here is 4 degrees, which gives us this angle is 4, right? And this is 26, so this becomes 7 degrees and this becomes 7 degrees. So the angle phi is 7 degrees plus 4 degrees, which is 11 degrees. Option A. Look at question 18. In this, what are they doing? We have a figure in which angle alpha is 8 degrees, right? Now all the line segments OA1, right? So we're talking about these line segments that are drawn, right? So after a point, we won't be able to draw these line segments, right? If they're all equally long, right? So we'll fall short at one point, right? So we need to figure out what that point is, right? So when we notice this is equal to this, right? So this angle here is also 8 degrees, and this angle here is 180 minus 8 minus 8, which is 164 degrees, right? So this will be 16 degrees, right? And this will also be 16 degrees. This is an isosceles triangle. And in the next triangle here, we'll have, so this will be 180 minus 16, which is 148, right? So this angle will be 148 and this angle here will be 24 degrees, right? And this again will be 24 degrees, and this will keep happening, right? So when will this stop? When will we no longer be able to draw a line, right? When the base angle becomes more than 90 degrees, right? So it can go up to, so we see a pattern forming here, 8 degrees, 16 degrees, 24 degrees, and it can go up to 88 degrees, right? But when it becomes more than 88 degrees, we won't be able to draw an isosceles triangle, right? Yeah. So the base angle should always be less than 90 degrees in an isosceles triangle, right? So how many lines will we get this way? So for each angle, we'll get one line, right? So A1, A2 for 8 degrees, A2, A3 for 16 degrees, A3, A4 for 24 degrees. So we'll get exactly 11 lines because we're not including the first line that we're drawing, right? So it is C, 11 lines. Okay, let's look at question number 19. Okay, what are we doing in question number 19? We have a trapezium in which AB is parallel to CD, right? So, and AD is perpendicular to B, right? This line is perpendicular to this. and the intersection of diagonals AC and BD gives us point O, and P is the midpoint of BD, right? So of this line, P is the midpoint and CP is the median. So a median of an isosceles triangle is also its altitude, right? So this is also 90 degrees. Okay, and we know that OP is 11 degrees. OP is 11 units, and we're being asked the length of AD, and we're being told it's m root n, right? In its lowest form. That's what this means, where m and n are positive integers and n is not divisible by the square of any prime. So we need to find m plus n, right? Okay, so what I notice here is this angle is equal to this angle, right? Alternate angles, and these two angles are equal, let's say phi and phi, right? So I can say that triangle BDA is similar to triangle DPC, right? Okay, because two angles are equal, right? This is 90, this is 90, and these two are 90. And we can also say that because P is the midpoint, if this length here is x, this whole length is 2x, right? And this length here, dp is also x, right? What we're saying is that BD is equal to 2dp is equal to 2 times bp is equal to 2x, right? Okay, and now we have these two triangles are similar, so the ratios of sides are equal. So BD by dp equals dA by PC equals AB by CD, right? And this actually equals 2, right? Because BD equals 2dp, right? So we have this also, and we can also consider these two triangles, they're similar, right? Triangle ADO is similar to triangle CPO, right? Because two pairs of angles are equal, phi and 90 degrees, right? So we also have AD by CP is equal to DO by PO is equal to AO by CO. So from the previous triangle we have DA by PC is equal to 2, right? So we can say that AD by CP, right, it's the same ratio, it's 2. So this, all these three are also equal to 2, right? And we took the length DP as x, right, and BD as 2x. So using that we can write DO equals x minus 11, and PO we know is 11, right? So x minus 11 by 11 equals 2, so which gives us x equals 33, right? So if x equals 33, now what do we need to find? We need to find this this side AD, right? Now using this relation here, AB is equal to 2CD. We know length of CD is 43, which gives us AB is equal to 2 times 43, which is 86, right? And similarly, we just found X, right, which is DP. We can also find we can also find 2 times of dp, right, which is bd. Bd equals 2 times of dp, 2x, which is 66. So in triangle abd, we know two sides, right? We know one of the sides is 86 and one of the sides is 66. Now we need to find this side, right, AD. So AD square is equal to 86 square minus 66 square, which gives us 20 into, so AD is equal to root over 20 into 86 plus 66 is 12, 140, 152, right? So we have AD equals 4 root 190 in its lowest form. So M is equal to 4, N is equal to 190, M plus N is equal to 194, right? Which is option C. Okay, let's see question number 20. In triangle ABC, lines are drawn parallel to the base BC as shown. Okay, so all of these lines are parallel, separating the other two sides AB and AC into 10 equal parts. So all these parts are equal, right? If we mark all of these as, let's say, B1, B2, B3, or let's make a bigger diagram, right? So here if all of these points so if all of these points are B1, B2, B3, right, this point, B4, and so on up to how many lines are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 lines, B9, right? And if we have these points as C1, C2 up to C9, right? Now triangle B1 C1 is similar to triangle ABC, right? The smallest triangle is similar to the biggest triangle, right? And all of these triangles are similar because we have parallel lines, right? All these triangles that are formed, this one, this one, this one, this one, all of these are similar, right? So we know that AB1 by AB is equal to 1 by 10, right? And ratio of areas is the square of the ratios of the sides, right? So if we take the big triangle to have an area of A, right, then the smallest triangle will have an area 1 by 100A, right? So area of AB1 C1 equals A by 100, right? And similarly, so how do we find the area of the second gray region? So it's this whole area minus the area of the second triangle, right, which is, and we know that this by the whole length is 3 by 10 and this by the whole length is 2 by 10, right? So the areas will be in the ratio 9 by 100 and 4 by 100. So we'll have 9 by 100, 9a by 100 minus 4a by 100, right? So if we keep doing this, we'll get the area of the shaded part is a plus 9a minus 4a plus 25a minus 16a plus 49a minus 36a, whole thing divided by 100, right? So the area will be a plus 5a plus 9a plus 13a by 100, which gives us 45a by 100, and we took the area of the bigger triangle as a. So the percentage will be 45a by 100 divided by a into 100%, which is 45%, right? So the answer is 45. Okay, let's see question number 21, right? So we're being told a plus b plus c is 0 and abc is 78, and we're being asked what a plus b plus a plus b into b plus c into c plus a is equal to, right? A plus b is equal to minus c, b plus c is equal to minus a from a plus b plus c equals 0, and c plus a equals minus b. So this product becomes minus of ABC, right, which is minus 78. So the answer is C, minus 78. Okay, let's see question 22. Okay, so a certain engine's rotation speed increases, its temperature also increases at a constant rate. This is important. Okay, the table compares the engine's rotation speed and its temperature, right? At a temperature of 100 degrees, so yeah, slowly as the rotation speed increases, the temperature is also increasing, right? At a temperature of 100 degrees, the engine will break down. What is the maximum rotation speed that the engine can attain without breaking down, right? Okay, so this can keep increasing, right? So for every 2 degrees, for every 2 cycles per second, the temperature is increasing by 1.6 degrees Celsius, right? So how many more degrees does it have to increase to become 100? 100 minus 27, so 73 degrees. right? So if it increases by 2 for every 2 cycles, right, what will the rotation speed end up being at 100 degrees Celsius? So 15 plus so it increases 1.6 degrees for every 2 rotations. So for it to increase 73 degrees, we'll have to do 73 into 2 by 1.6, right? So this will be our answer. We'll get 15 plus 73 by 0.8, which will give us 15 plus 91.25, right? So this is 106.25. So the maximum rotation speed that the engine can attain without breaking down is 106 cycles per second, right? Okay. The 23rd question. Students of a class are made to stand in rows. Okay, if one student is extra in a row, there would be 2 rows less. If one student is less in a row, there would be 3 rows more. Okay, let's say there are X rows and Y columns. Right? And the total number of students is XY and it remains constant. Okay, so if one student is extra in a row, okay, that means there are Y plus 1 columns, there would be 2 rows less, right? Which would, but the total number of students won't change, so we can equate it to XY, right? And similarly, if one student is less in a row, that is one column is less, right, then there would be 3 rows more, and this would also we can equate to XY. So we'll get XY plus X minus 2Y minus 2 equals XY, right? XY gets cancelled, so this is equation 1, and XY minus X plus 3Y minus 3 equals XY. Again we can cancel the XY's, right? So we have, this is our second equation. Let's add equation 1 and equation 2. We get Y minus 5 equals 0, so Y is equal to 5, and from this we get X is equal to 2Y plus 2, which is 12. So total number of students is XY, which is 60, right? Okay, let's move on. Okay, so in the 24th question, we're asked what is the biggest integer smaller than this. Okay, let's take this value to be X. All right, X equals this. Let's, so I mean X is obviously greater than root 20, right? And it's less than the infinite sequence, that is 20 plus root over 20 plus root over 20 plus root over 20 up to infinity, right? So let's say this thing here equals Y. So Y equals root over, so this thing y equals this thing here. Right? I'm sorry, square root over this, right? So y square is equal to 20 plus whatever's inside it, right? So, but whatever we get here is also the same as y, right? It's the same as this. So y square equals 20 plus y. This becomes a quadratic in y. Y square minus y minus 20 is equal to 0. Y is equal to 5 or minus 4, right? But I mean, obviously this can't be equal to minus 4 because it's positive. So this is not a solution. Our only solution is y equals 5. So what we had, our x in the question is greater than root 20, which is greater than 4 and is less than 5, right? So x lies between 4 and 5. So the biggest integer that's smaller than this big root here is 4, right? Okay, let's look at the 25th question. In this, we have a sequence fn which has f1 is equal to 1, f2 is equal to 2 and fn is equal to fn minus 1 into fn plus 1, right? So this thing over here, we can write it as fn plus 1 is equal to fn by fn minus 1. This just means that the next term, right, is the ratio of the previous two terms, right? So f3 will be equal to f2 by f1 and f4 will be equal to f3 by f2 and so on, right? So let's see how the sequence goes. So we'll have 1, 2 and f3 is 2 by 1, which is again 2, f4 is 2 by 2, which is again 1, f5 is 1 by 2, which is half, f6 is 1 by 2 by 1, which is again half, and f7 is half by half, which is 1, f8 is 1 by half, which is 2, right, and so on. Now if you see, we got the first two terms again. Now this thing will repeat. So the sequence repeats every 6 terms, right? So every 6 terms the sequence repeats. So 2022 is a multiple of 6, so it will keep repeating until the 2022nd term, that is 1, 2, 2, 1, half and half. So this half is the 2022nd term. And then we're considering the first 2025 elements. So the next 3 elements after 2022nd element will be 1, 2 and 2, right? So we notice that for every 6 terms, 4 of them are integers, right? And then we're left with 3 terms. So we divide the 2022 numbers by 6 and multiply it by 4 and we add 3, right? So we get 1348 plus 3, which is 1351, which is option C, right? Okay, let's move on to the 26th question. What are we being asked? We're asked that if n is the smallest positive integer whose sum of digits is 2026, what is the sum of digits of n plus 2026. Okay. Alright. So for n to be the smallest such number whose sum of digits is 2026, right, we would need to have all digits, I mean as many digits as possible as 9, right? Only then the number will be the smallest, right? So the closest multiple of 9 is 2025, right? So 2025 is 9 into 225. So our number will be 1 followed by 225 nines, right? And this number is actually 2 into 10 power 225 minus 1, right? This is our number n. And n plus 2026 will be 2 into 10 power 225 minus 1 plus 2026, which is 2 into 10 power 2025, 10 power 225 plus 2025, which will be something like this: 2 followed by many zeros and then 2025 in the end, right? So the sum of the digits of this number is 2 plus 2 plus 2 plus 5, which is 11, right? Okay, let's move on to the 27th question. Okay, in this, we're given that AB and AC are equal sides of an isosceles triangle ABC, in which this triangle inside it is equilateral, right? So these angles are 60 degrees, all these angles are 60 degrees, and these two angles are equal, right? Because the bigger triangle is isosceles. Okay, so we're asked to find the relationship between these three angles A, B and C, right? These three, A, B and C. Okay, so what can we say about this angle over here, this one, right? So can we say that this angle is 180 minus 60 minus B, which is 120 degrees minus B, right? So this angle B here, this one here, will end up being 180 minus 120 minus B minus A, right? Which is equal to this angle here. Let's try to find what that angle will be. So this angle here will be 120 minus A, right? This one over here, this one, right? This will be 120 degrees minus A. So this angle over here, angles ACB, will be 180 minus 120 minus A minus C, right? So we have B minus A is equal to A minus C. So what do we have? B plus C is equal to 2A. A is equal to B plus C by 2, which is option D, right? So let's look at the 28th question. Elvis and Jimmy started learning the guitar recently. 2 weeks ago, Elvis had been learning 5 times. Okay, let's say Elvis has been learning for X days and Jimmy has been learning for Y days. So 2 weeks ago, that is X minus 14 equals, so Elvis had been learning 5 times as long as Jimmy. So 5 times Y minus 14, right? And similarly, X minus 2 equals 2 times Y minus 2, right? Let's subtract the two equations. We get minus 12 equals 3y minus 66. So 3y is equal to 54, y equals 18, which gives us x equals 34, right? So how many days before Jimmy did Elvis start learning the guitar? That means we need to find the difference of 13 minus 18, which gives us 16, right? So it's option B. Okay, let's look at question 29. So we discussed in a previous question, right, in the parallelogram question, that the median of a triangle divides the triangle into two triangles of equal area, right? So this area will be equal to this area because F is the midpoint of AE, right? Here it's given. F is the midpoint of AE, right? So this yellow area will be equal to, let's say, this red area, right? So BEF is 5, so this will also be 5, and similarly E is the midpoint of BD, so area of ABE will be equal to area of AED, right, this triangle here. So that area will be 10. Similarly, D is the midpoint of AC, so this big triangle's area will be 5 plus 5 plus 10, which is 20. So the area of triangle ABC is 5 plus 10 plus 20, which is 40. So it's option C, right? That brings us to the last question. So, okay, in the first few sentences, an ordered pair is being explained, right? Okay. So A into B plus 63 is 20 times its LCM plus 12 times its HCF. But we also know that LCM into HCF is equal to the product of two numbers, right? So we can replace A into B with L into H. L into H equals 20L, L into H plus 63, right? 63 plus L into H equals 20L plus 12H. We bring all the terms to one side, we get L into H plus 20 L, minus 20L minus 12H equals minus 63. When we send the 63 to the other, 63 to the other side, right? And we can add 240 to both sides. So LH minus 20L minus 12H plus 240 is equal to 240 minus 63, right? So we have L minus 12 into H minus 20 is equal to 240 minus 63, which is 177, is it? Yeah. And 177 can be written as 1 into 177 or 3 times 59, right? And 59 is a prime. We can't reduce this further, right? So these are the possibilities. And LCM is always greater than or equal to the HCF, right? And LCM is always divisible by HCF. Right? Okay. So which gives us if L is equal to 189, H equals 21, or if L is equal to 71, H equals 23, right? This obviously is not a solution because 71 is not a multiple of 23. So we'll ignore this, but 189 is a multiple of 21. So we'll use this, right? So we have LCM is 189 and HCF is 21, right? So both the numbers are, so can we write A equals some 21x and B also equals 21, I'm sorry, and B equals some 21y, right? And A into B equals L into H, which gives us 21x into 21y equals 21 into 189. So xy equals, right here x and y have HCF 1 by the way, right? So x and y equals 9, right? The only way that x and y can have HCF 1 is when x equals 1 and y equals 9, or x equals 9 and y equals 1. So this gives us the two numbers as 21, 189 or 189, 21. So the only two ordered pairs are these two. So there are two possible ordered pairs. Alright guys, thank you. I hope you guys understood